Hello everyone, thanks for joining the GeoPits webinar. Welcome to our 7th webinar of the year 2024. We thank you for taking your time to join us and listen to what we have for you today. Before we dive into today's webinar, I want to briefly introduce GeoPits and what we do. So GeoPits, we act as a DBA partner for companies. We help companies to monitor and improve the performance of the database. We are Microsoft Silver partners in data platform, and recently we are also partnered with MongoDB on the data platform as well. So any form of database, be it MS SQL, MySQL, Postgres, MongoDB, be it on cloud or on-prem, we help you with all the service-related aspects of database, from performance tuning to managing the entire database. Our engineers will be present 24/7 around the clock to help with your database needs. So these are few of our expertise and certifications. So our webinar for today is titled Maximizing Performance and Cost Efficiency in Amazon RDS and Aurora PostgreSQL. We have Anurag, who will be the speaker for today's webinar. Just to introduce Anurag briefly, Anurag is a senior DBA. He has very good experience in PostgreSQL Server and also has worked in many projects and brought excellent results. Now over to you, Anurag. All the best for today's webinar.
Hello everyone, and welcome to our webinar session. My name is Anurag Shukla and I am database administrator with 6+ of experience in this field. So today I will be sharing insight of monitoring strategy and cost efficiency in AWS RDS Postgres. Thank you for joining us. Let me share my screen. Is my screen visible to everyone?
Yes, Anurag, your screen is visible.
Okay. So for today's webinar, the agenda will be monitoring strategy and cost efficiency in our Postgres database. So what is like Postgres RDS? So Amazon RDS is a managed database services provided by AWS. It allows users to set up, operate, and scale PostgreSQL database in the cloud easily. It simplifies the process of creating and managing Postgres databases with just few clicks. You can launch fully functional database instance without the need for any extensive configuration or any administrative task. It comes up with a variety of built-in tools for the monitoring, both hardware and database health. These tools include CloudWatch for the tracking metrics, enhanced monitoring for the deeper insight, and the performance insight for analyzing database performance. These tools help you to maintain optimal database performance and quickly identify any issue. RDS makes it easy to scale your database resources based on your workload. You can adjust the compute capacity and storage size as needed, ensuring that your database can handle different level of demand without compromising performance. Configuring high availability and automated backups is very straightforward in RDS Postgres. You can enable multi-AZ deployment for the high availability, ensuring that your database remains operational even in the event of failure. Automated backup and snapshot helps protect your data and simplify recovery process. Moving to next slide. What is like Aurora? So Aurora PostgreSQL is a flavor of RDS with modification. Aurora PostgreSQL is fully managed relational database engine that compatible with Postgres, but it comes with enhancement that make it more powerful and efficient. It incorporate several optimization and changes to the Postgres source code to improvement performance and availability. It ensure high availability by replicating data across 3 availability zones. The multi-AZ architecture provides robust fault tolerance and automatic failover compatibility, ensuring your database remain operational even in the event of availability zone failure. It automatically scale storage and IO to meet your application demand. Storage can grow up to 128 TB, and I/O performance scales seamlessly with your workload, eliminating the need of manual intervention. It provides a reader endpoint that distributes read queries across multiple read replica. This built-in load balancing helps optimize query performance and ensure efficient use of resources. In the event of node failure, Aurora Postgres automatically recover the failed node without requiring manual intervention. This automated recovery process minimizes downtime and ensures your database remains operational. It is designed to handle write incentive workload efficiently. Its architects support high throughput and low latency, making it ideal for application with demanding write performance requirement. It automatically failover to a reader node in case of failure based on the failable priority. And this process is transparent to your application when you are using cluster endpoint. This ensures minimal disruption and continuous availability to your database. So the next part is like monitoring strategy in our RDS or Aurora instances. So for the monitoring, like hardware monitoring and our database monitoring, we have CloudWatch metrics. AWS CloudWatch provides detailed monitoring metrics such as CPU utilization, memory, disk, IOPS, network performance, disk queue depth, and many other metrics are there which help us to monitor the database. These metrics help you understand the hardware performance and identify any potential issue. We can create alarms on these metrics and integrate with Slack or Grafana on call or PagerDuty using AWS SNS. So AWS SNS can be configured to send alerts based on CloudWatch metrics. This ensures that you are promptly notified for any critical issue. By integrating AWS SNS with Slack or to receive real-time notification directly in your Slack channel. We can use PagerDuty for incident management or on-call rotation, ensuring that critical alerts are escalated and addressed properly. For the database auditing and login, we have a extension like PG audit extension. This extension is to log database activity, include queries and changes to data. This is essential for compliance and security auditing. And for the long retention period of our logs, we can download the logs to S3 for long retention period and analysis. Also, we can export logs to CloudWatch for the centralized logging and easy access of our historical data. Database monitoring can be easily taken care by creating custom dashboard on Grafana to visualize key database metrics such as database growth or table growth. Grafana allow you to create real-time interactive dashboard for the better insight. Similarly, we can use CloudWatch dashboard also. For that, we can use AWS Lambda functions and create custom queries, custom metrics dashboard that can help us to look into deeper inside of the database. We can use custom script for monitoring such as long running blocking session, any table plots. We can use these script and integrate with AWS SNS to send notification on Slack, email or mobile when these incident occurs. This helps optimal database performance and efficient storage use. We have some useful extension for database performance like PG ProcTab, PG statement and auto explain. So PG ProcTab, this extension provides system level detailed information that are useful for troubleshooting performance issue. PG statement is an extension that is useful to track execution statistic of SQL statement, helping you to identify and optimize a slow query. Auto explain is an extension that logs automatically execution plan of slow query, providing a valuable insight into the query performance and helping you optimize your database operations. By implementing these monitoring strategy, we can ensure that our RDS Aurora Postgres database are running efficiently, securely, and with minimum downtime. fine-tuning the parameters. So in Amazon RDS, the parameters are managed through different parameters group that control the behavior and configuration of our database. Basically, we have two types of parameter group, like cluster parameter groups and parameter group. So cluster parameter group applies settings to all instances within a database cluster. It's typically used in Aurora, where setting needs to be consistent across multiple instances. DB parameter group is a parameter group applies to individual instances, allowing more control over a specific instance. There are several key parameters to focus on, but here we are going to have a quick look on few important parameters to optimize our database, such as work memory. We say it as a work mem. So this parameter controls the amount of memory allocated for internal short operation and hash table before writing to temporary disk file. Properly tuning work memory can significantly improve query performance. Second is maintenance work map. This parameter sets the maximum amount of memory to be used for maintenance operation, such as vacuum, create index, or alter table, or adding foreign key. This increasing this maintenance work memory can speed up your maintenance task. We have few logging parameters like logmin duration statement, log statement. So setting the logmin duration statement sets the minimum execution time above which all the statements will be logged into log file. Suppose if we set it to 1 second, so all the query which are taking more time than 1 second will be logged into log file. Log statement is another parameter which control SQL statement, which type of SQL statement are logged. If we are setting to all, so all the statements will be logged into log file. Another parameter is there, that is shared buffer. So the shared buffer parameters determine how much memory is dedicated to catching data, which can significantly affect read performance. In Aurora PostgreSQL, it is recommended to allocate approximately 70% of your available memory. And in RDS, it is said to have a 25% of your memory. But this can be different in different use cases, and we can set accordingly, considering all other parameter together. pgtune is one of the third-party tool that can help us to identify the better use of this parameter. Another parameter is there like auto vacuum. So auto vacuum parameters helps to enable auto vacuum feature. You can enable or disable it. There are some more auto vacuum related parameters like auto vacuum threshold. So minimum this helps to set minimum number of updates or deleted tuples that needs to be triggered for a vacuuming a table. Auto vacuum max worker is a parameter that sets the maximum number of auto vacuum process that can run at the same time. Another parameter for the log for the auto vacuum, like important parameter we can take is log auto vacuum minimum duration. That's logs auto vacuum action that makes longer than this amount. By careful tuning this parameter, you can optimize the performance, reliability, and efficiency of your RDS Aurora Postgres database. Regularly reviewing and adjusting these settings based on your workload can lead to significant improvement in the database operations. So our next slide is related to cost efficiency. So for the identifying the right instance type. So when identifying the right instance size, we consider always price and performance. Balancing cost and performance is a crucial when selecting the right instance for your RDS Aurora Postgres database. Understanding your workload requirement and how different instance type perform can help you make informed decision and maximize both efficiency and cost effectiveness. To identify the right instance of your workload, we need to analyze workload requirements, determine the CPU, memory, and IO needs of your application. Different workload may benefit from different instance type. We can use tools like AWS pricing calculator or a third party website called Vantage to compare different instance type. That can help us to identify and compare the instance class. Ensure that the chosen instance supports IO throughput, input output throughput. You have provisioned. Insufficient IO can become a bottleneck and degrade performance. So a Vantage website can help you to see like the instance type which you are choosing supports the IO operation that you are going to provision for your instance. Aurora has some limitation on IO and bandwidth based on instance type. Check the specific capabilities and limitation of Aurora instance type you are considering to ensure that they meet your needs. For the connection management, we can use RDS proxy or PG bouncer. So RDS proxy helps manage and scale connection in your database. It improves application availability and performance by pooling and sharing connection, reducing the overhead of opening and closing database connection. PG bouncer is also a lightweighted connection pooler for the PostgreSQL. It can help manage database connection efficiently, reducing the load on the database and improving overall performance. By carefully selecting right instance type and connection management tool, you can optimize both performance and cost of Aurora RDS Postgres database. Regularly reviewing and adjusting your instance type based on your workload will help maintain the cost efficiency over time. Uh, For the cost efficiency, like identifying the right instance, AWS gives a gravitation instance such as R6G, offers a compelling price to performance ratio. These instances are designed to provide significant cost saving while maintaining high performance. R6G instances are approximately 10% cheaper than R5 instance with the similar configuration, making them a cost effective choice for many workloads. It is essential to evaluate your workload to select the most suitable instance type. Different workload have different requirement. So understand your specific need is a crucial thing. There are many performance testing tools we can use for the testing, such as you can use PG Bench for the benchmarking tool for Postgres. You can use JMeter tool that can also help in the benchmarking for your workload analysis. This helps in understanding how different instance type will perform under your specific workload configuration. If your workload experience high availability such as peak during certain period of a day, consider using Aurora serverless. This instance type automatically scale based on demand. Ensure that you are only paying for the resource that you actually use, which can lead to significant cost saving during low demand periods. By incorporating gravitation instance evaluating workload with tools like PGBench, JMeter, you can consider Aurora serverless for variable workloads. You can optimize cost efficiency while maintaining high availability for your RDS or Aurora databases. So cost efficiency by reserving the instance type. Once we identified our instance for the reserve for our database part, we can take it as a reservation, analyze your business need and identify the which instance we are going to use. Reserve instance can save up to 40% compared to on-demand pricing. Consider reserving instance for a stable long-term workload where the compute capacity requirement is predictable. AWS offers various commitment periods such as partial upfront, 1 year upfront, 3 year upfront for reserve instances. Choose the one of the best that aligns with your business need and budget. If you have multiple AWS accounts with multiple instances, consider purchasing reserve instances through an organization account. You can share the uh, purchase the reserve instances across all other accounts, ensuring that the reserve capacity is utilized efficiently. By strategically reserve reserving instance based on business needs and leveraging centralized purchase through AWS organization account, you can achieve significant cost saving and ensure efficient use of reserved capacity. This approach helps in maximize and financial benefit of reserved instances while maintaining flexibility and performance. So cost efficiency using IO optimized instances in Aurora. So AWS has introduced optimized instances where the cost for the IOPS is zero. This leads to a significant saving of workloads with high IO requirements. These instances are ideal if your IOPS cost exceeded 25% of your total Aurora cost. The total Aurora cost is compute cost and storage cost. Two things are there to consider cost consideration. One is compute cost. While the IOPS cost is zero, the compute cost for the IO optimized instance is approximately 30% higher compared to standard instance. Second thing to consider is the storage cost. The storage cost for IO optimized instance is double as compared to a standard one. Despite the higher storage cost, these instances can be cost effective for the high IO workload because they are eliminating IOPS charges, leading to overall savings. By utilizing IO optimized instance of workloads with high IO demand, you can achieve substantial cost saving, especially when IOPS costs are significant portion to your total Aurora expenditure. This strategy allows for more predictable and managed costs, ensuring optimal performance without the financial burden for the high IOPS storage. So cost efficiency, like with the use of storage, we can regularly remove unwanted and old data to lower our storage cost and boost database performance. Move rarely used data and to the cheaper storage like Amazon S3 or Amazon S3 Glacier, which offers lower storage cost compared to database cost. Use table partitioning to manage and organize your data efficiently. Partition make it easier to purge old data by removing the entire partition rather than deleting row wise in your table. Partition can also enhance query performance by allowing the database to scan only relevant partition, thereby reducing the IO and improving response time. We can use write clones to quickly create copies of your PostgreSQL Aurora databases for testing and pre-prod environment. This method allows you to refresh your test environment without needing to duplicate the entire datasets, saving time and storage cost. Clones share the same underlying data as the original database until the changes are made to the write clones. This means that until you modify the data, the clones are very little additional storage, making them much more efficient than creating the full copy of the database. By implementing this strategy regularly, regular purging unwanted data, archiving the data to cheaper storage, creating partition, and using copy clones, you can significantly optimize your storage costs and maintain an efficient and cost-effective database environment. So, like cost efficiency that helps in backup storage. So, uh, in the Aurora and RDS, we use basically for a snapshot for the backup purpose. We can replace a snapshot with logical backup tools like pgdump. Logical backup can reduce the costs associated with storing a snapshot by compressing data and minimizing the amount of storage required. You can use the snapshot to restore your database to a new instance. Once new restored instance is available, we can use pgdump with high compression level to take backup of the database for the new instance. This approach avoids impacting the production instances while performing backup. We are taking backup from the newly created instance. This ensures that our primary database remains unaffected during the backup process. This strategy particularly benefit in place where long-term retention period is required. Logical backup such as pgdump can be more cost-effective for long-term storage compared to the continuous snapshot. pgdump has a option where a compression is available that can compress up to 90%, significantly reducing the storage space required for the backups. Once these backups are available, we can move these backup itself into S3. This will save more cost. When doing the pg dump, use the directory format with higher compression level. This format allow you to for more backups and can handle large database more effectively. By using logical backup tools like pgdump and restoring your snapshot from backup purpose and optimizing database operation, you can significantly reduce backup storage costs while ensuring efficient and effective database management. The pgdump is the tool which can help you to reduce your snapshot 90%. If you have around 1 TB of data, the snapshot which can restore and create 1 TB database. By taking the dump, you can reduce it by 90%. It will make you only available by 10 GB. So this will help saving costs a lot more. So we welcome your questions now.
So thank you, Anurag, for providing a comprehensive overview of maximizing performance and cost efficiency in Amazon RDS and Aurora Postgres. Now we're at the end of this webinar. We'll be having a quick Q&A session. If anyone has any queries or questions in regards to today's webinar, please feel free to ask. We would like to wind up today's session. Thank you everyone for joining, and always keep a lookout for more upcoming webinars in the future as well. We will be posting the highlights of today's webinar on our YouTube channel, and also follow us on LinkedIn so you will be updated on the new webinars that will be coming up in the future. Thank you everyone for taking your time and joining this webinar, and have a great rest of the day.
Thank you, everyone.
Yes, thank you, Anurag. Thank you, everyone.
Thank you.